Tan x dy dx plus y equals 2 sine squared x. It's not in standard form, is it? Because this is the problem. So let's divide by that all the way through then. So divide by tan x gives... So divide this term by tan x, we just get dy dx, don't we? dx plus y over tan x. Tan x is sine over cos x, so I'm going to split that up to sine x, and the cos x underneath can swing up to the top. And then 2 sine squared here. Divide by tan x, which is sine x, over cos, and the cos that's underneath the underneath will swing up to the top onto it. One of these signs will cancel, so let's do that now. And we get 2 sine x cos x. So let's have a look at this then. Let's circle the p. Everything but the y, whoops, is the p. So let's do that. So it's all this stuff here. So here, we can now go with the integrating factor. E to the integral p, which is cos over sine, which is an integral of cos, which is a standard integral, it's log sine. And you can see that just by differentiating this function of a function. 1 over log of something, 1 over something, multiplied by the something differentiated, which is cos. So it's e to the log sine. E to the log is the inverse of each other, so we'd just be left with sine x, won't we? So there's our integrating factor. Let's multiply that throughout then. Multiply by sine x gives, so let's do that. See what we get. So sine x times dy dx. Sine x times this, one of the signs will cancel and you'll just get cos x times y is equal to sine x times this, 2 sine x cos x. So we'll get back to the sine squared x times cos x here. Good. So now we circle the u and the v, and hopefully we should be able to see in our mind's eye and verify that we've done it correctly, because this should be u dv dx plus v, which is there, times du dx, which will be cos. So that's fine, that's a derivative of product, everything looks good there. So that implies then that d by dx of uv, u is y and v, u is sine x, so it's sine x times the y uv equals 2 sine squared x cosine x. Now we can integrate both sides then, because it's a standard separable equation. So integrating then gives, integral of the derivative is just the object itself, so that's sine x times y, and then on the other side we've got the integral of 2 lots of sine squared x times cosine x dx. This is just a function of a function, if you see it, I hope. This is sine x times y, and this will be, because the sine differentiates to cos, you can look at that and say, oh, it's sine cubed over 3. Right, that differentiates to then, in your mind's eye, 3 will cancel this squared, multiplied by the something differentiated, which is the cos. We still need a 2 there, don't we? So we better put that in, plus a k at the end. So let's just check that again. Differentiate this then to check we've got this integrand here. So the 3 comes down to cancel with that 3 to leave sine squared multiplied by the something differentiated, which is cos, and the 2's already there. So that looks good. So there's our answer then. So now we just tidy it up if we wish. So what do we get then? Divide by sine x all the way through. Y equals, divide this by sine x, you get 2 sine squared over 3 plus k over sine x, which we can leave as is.